Hey everyone, how's it going? Happy Monday. Getting things set up here. Have a new little setup going, so I'm gonna double check that everything's looking. What has been your favorite, most difficult project so far? Well, probably anything related to making my own AI. So yeah, when on the previous streams we've written our own AI framework from scratch. We also using any of the existing AI frameworks. That was my favorite. That is one of my favorite. Let's see, I think that was a Discord. Let's see, that was a Discord question over here. Probably to someone different. I don't want to worry about that. All right, today what we're going to do is we're going to be working on C basics. We're going to just, get a little refresher on writing code in C. And see what, one of the things I wanted to try was, what is the is this right here what you see on the screen? Is this the minimal C? Can you get away with it? Hey, MD, how's it going? Good to see you. Good to see you. Happy Monday. We're going to work on some C basics today. We're going to do things like some string manipulation. Maybe we'll work on numbers, variables, just to do like a little refresher to make sure that we're all up to speed on everything. Oh, one thing I wanted to check really quick. 1 second. Hold on. Let's see if I can double check. All right, good. All right. Checked it. That only took like a few seconds. All right. So let's get into it. One of the things I wanted to do was see what is the absolute minimum C program. Is this it right here? It enters and exits and done? Is that it? I'm actually really curious about it. Hey Torva, how's it going? Hey Savon, good to see you. Hope you're doing well. Torva, good to see you. Happy Monday. So the thing that we wanted to do last week was actually, because everyone you're asked, why don't we do some C basics? Let's get back to some basics on C. Why don't we try that? And you know what? I got sidetracked because I had to do some things and I figured I would do them on stream, right? Some like overall 2026 expectations for software engineering. We did that. We got that done. It's all launched. The favorite stream on YouTube. Thank you, Savon. Thank you. That's really great feedback. That's awesome. Hey, just a random learner. Hi. Do you still remember me? Of course. Of course. You expected. Yeah. You've been over there on the purple. You've been over there on the purple for a while. It's good to see you. Good to see it. So today we're going to do C basics. And the first thing, I haven't done this. I don't know exactly how before. I've never tried this. We're just going to see if we can get the absolute minimum C program to compile, build, and run. Now, what you see on your screens, a few keystrokes. I don't know if that's enough or if it's too much. So you love C? Nice. Me too. That's what my technology is written in. Is written all in C. You might think, oh, why don't we do C++? We can do everything. We can do it. Oh, I'm actually really excited. Hey, how's it going there? Wish. What you saying things? They're saying things. RG, good to see you. Welcome on in. Good to see you. Happy Monday. This is so. Oh, wish. I'm really happy you're here. We're gonna do some C basics. I'm actually really excited about this. This is pretty neat. You can stay, hang out, and if you want, enjoy, or let's see. I'm actually really curious. So is this the minimum? Let's see. We'll find out here. So I know we can use clang. Let's see. And then I want to not. Okay. Hey, well, and happy that you stopped by. I'm happy that you stopped by, even if it was for just a brief moment. All right, let's go over here. So mine.c. It compiled very minimal. I wonder if we could even get rid of the 0. Can you do that? I'm actually really curious. Oh, no. Wait, what if it didn't like that? All right. What if we just did main? Is that something, is it mandatory mint? It is mandatory integer. It is, it wants it to be an int. Although, what if we don't return anything? It still works. Right. What's the absolute minimum? I'm actually really curious about this. Which GUI library for Rust? Oh, what is it called? My favorite. It is sort of like the Electron. It's the Electron replacement. Let's look that up really quick. Electron Rust lib alternative. All right, what is that called? Tory. It's called Towery or Tory? Towery. Check it out, Towery. Here we go. I'll pull this up over here. Here we go. If you want a UI library for Rust, as long as you're not doing a TUI, a terminal user interface, if you're doing like a desktop app, Towery is the way to go. It's the new way to go. Savon, you may eject midstream. All right, sounds good. Take care of yourself. be comfortable and good. The mother of all languages has said, yeah, I know. See, you can't do void in main. I want to see if I can. Primary lang is C++, similar to C. Nice, RG, nice. Well, we're gonna be hanging out with that today. We're gonna be trying this. So apparently you can build this, right? So here's the absolute minimal. Let's see, and then we can probably. So here we go. Is this the absolute minimal C? Is it gonna build? It built. Okay, so let me see here. So a dot out. So I think we can do dash O, and we say main. All right, MV RMA LS. Okay, so we could do / main. There it goes. We did it. We did it. Oh, Towery. Yeah, Towery is a good one. I like Towery. All right, let's pop this back over here. Let's see really quick. Wait, you built and replaced a multi-pop real-time data stream network written in C for readability and speed? I mean, that's kind of what I did. Although I didn't. I started with C. We started with C. So, and now we're moving to Rust. I believe that you know C, but I doubt that you had mastered C. Yeah, you might be right. You might be right. There's a lot of things. I haven't written C for quite a while, actually. For quite a while. Mostly these days, Python and Rust, JavaScript are the more common, and TypeScript are the more common things. C-Lang, like the LLM VM version of C. Yeah, so you could use GCC or C-Lang. On Mac, they like C-Lang. On Mac, it likes C-Lang. So that's what we'll be working on today. So I wonder what else can be. So we have to set Copilot disable. We are going to disable the AIs here, so we don't have any special assistant. All right. You've always compiled with GCC. Yeah, me too. Even my technology, PubNub's still in C++. C-Lang works more performant on Mac. It's more performant on Mac. And it's also got a lot of some extra compiler flags that you can use for safety considerations, which I think is pretty nice. I think it's pretty nice. All right, so now that we've got a minimum, we don't have to return. Isn't it neat and see? Just like you say, there's going to be an integer returned. Nope, you didn't return anything. It just didn't return. It returned nothing. I'm actually kind of curious. What is the default return if nothing gets returned in C? I'm actually kind of curious. Obviously, I think the compiler will get angry if I do int test and then I return 0. I wonder, can we print F? Can we print? So it's here. Int t equals test. Does that work? Can we do this? It's been a while. I'm kind of curious if we could do that. Always nice, probably due to LLVM abstraction, I'm guessing. Also more modular, and the linkage, I assume. I think so. We'll find out. We'll find out. Okay, so T doesn't. Oh wait. Oh right. Don't we have to? How do we do this? Do we do it like something like that? Percent. Can we do that? I forgot how to do this. And see, we're gonna find out. All right, we're gonna try to print an integer. That's what we're gonna do. Oh, we're gonna try that. Oh, do we have to include something? Let's see. Include std.io. Wait, .h. Something like that. To get print going. I'm actually kind of curious. Let's see if we can do just a regular print first. Okay. We don't have that anymore, so let's do a regular print. We're just gonna print hello. Hello, exclamation point, \n, done. Okay, let's see if that works. Include the prototype. Oh, I forgot about prototypes. Thank you. Okay, yes. All right, so we need to, right? We have to do int test like that, something like that, right? Is that the prototype right there? I forgot about that. Thank you. I always sleep at this time. Now I wake up the whole night only just to see experiencing C. I know, right? It's just a random. You do the -d. Okay, so %d for numbers. Got it. So D here. All right, let's see if that works really quick. Let's build this out really quick. Okay, that builds main. All right, so we printed hello. All right, we're getting our C basics back. We're getting them back. We're gonna get our memory going here. All right, so then we defined a prototype. What's really interesting is I defined a prototype up here. I'm pretty sure that's how you do the prototype. I think, right? You don't do it like this. I'm pretty sure you do it like that. And we didn't define it anywhere. And for whatever reason, it's still compiled. Isn't that neat? I'm sure there's some warning flags that we can throw in there that make it a little bit more, strict on the compilation. Finally, something you can relate to. All right, Xerxes. Good to see you. Happy Monday. Hi, Steven. Happy to have you here. All right. Let's keep getting into this. All right. So I am interested in, let's see if we can get this, let's get this test going here. So int, let's see if we can do this. And then we redefine that there. Okay. So let's do like, I don't know, 10. Okay. Is that going to build? No, didn't build. All right. We need to figure out why it didn't build. This is like the easiest things. It should be the easiest. Do you guys see what the problem is? We're gonna figure this out though. We will figure it out. Let's see. Build. No. Build. Yes. Okay. Int test. No. Previous definition. Int test. Oh. Wait. How do we define? Is that? Well, here. I know we can do this. That should do it. Because if we define it up there, you don't need the prototype. Yeah, I know. Figured some things out. Well, the prototype thing, I completely forgot about those. I know, right? The prior to ADT abstract data types. This brings memory from universities, right? Yep, back from the college days. University. All right, can we do this? Yep. Oh, wait, no. Hold on. Let's do... I like this better. Can we do end/main? So if it builds, then it runs. Okay, great. All right, see if you can print out the number. Hey, there we go. We're figuring things out. All right, test for prototype. Okay, cool. Thank you. All right, so if we did want to do the prototype, I believe you need to give a back bracket as well for prototype. Thank you. All right, so let's see, int test like that. Oh, right. And then we have semicolons everywhere. Everywhere's got to have semicolons except for include statements, right? All right, so is that going to build? Okay, good. Hey, there we go. All right, so we did need the prints for the prototype. We did. All right. So far, we've gone through it really quick. What have we only been on here for about 10 minutes now? We've got some of the basics happening. We're getting back to memory. We've did the minimal application. We're not even returning 0 here. We should be returning 0. I know we're supposed to return 0, right? Steve, there we go. From intro to CS, the intro. The original days. All right, so what we've got a variable, right? So let's say this is a number. Let's see, generate number. We'll make things like that. So you've got a prototype. Define the prototype so that other before defining the function. All right, you got to do that first. Are you learning C? So we're just revamping on C. We're doing the basics. We're getting started over. I remember it. I can edit it. I can manipulate it. I can do all the things I want with it. Structs. There's not a lot in C. There's loops. There's variables. There's memory allocation. There's structures, right? Structures and enumerations. What else is in C? Right? Standard-based libraries with standard-based data types, integers, chars, pointers. What else is in C? There's not a lot. So we're just getting back into it. And this is a welcome back to basics with C. So if anyone remembers, C is the way to go. All right, so what else do we want to do here? Let's write down a list of to-do. All right, I guess some to-dos here. To-do things to learn. All right, so strings, I guess chars, right? Chars. Let's do another to-do. Structs. Let's do structs. Can we do enum? I want to see enum. We'll do an enum. Maybe we could do some other things. Bit shifting in C. Right. Thank you. Just learner. I forgot. Right. Bit shifting. To do bit shifting / bitwise operators. Right. Remember those? Remember these? What do you even use those for? or you can use them for some interesting things if so you want. Keep track, actually being able to leverage the full binary of the data that you allocate and using it as a flag or a feature. There's a lot of neat things you can do there. Buffer underruns and overruns. Oh yeah, those things that you got to be careful about. You got to be careful, right? To do careful about memory boundaries, right? Over under runs. You got to be careful. Oh right. That's right, Siobhan. That's right. You can create a .h file, the header files. You define prototypes there and then include the H file into the source code. So that way you have a black box abstraction. You can only use interface. Yes, that's a good point. So where the prototypes are, you build, right? Every C file has an object output. Every C file has an object file output when you compile it, right? When you compile it. And then in order to use those methods or those functions that you've written in that file, in another file, you can write a header file that then you can use to include, right? It's like what we did with this here. So you see a header file here. So let's do that. Let's also cover header files. Header files.h. We can do that as well. And then we can go, we can, go from there. So let's see if we can remember all these things. Let's try a pointer. Let's try a char pointer. And I think if we do a char pointer, we have to do a malloc, right? We got to do a heap allocation. I'm pretty sure we got to do heap allocation. All right, generate number. Let's rebuild this to make sure it works. Number. There we go. Maybe heat step allocation and segmentation where doing general stuff. Yes, okay. We'll write down that as well here. All right, so heap/stack allocation, differences and things like that, and when and where to use and whatnot. Oh, static. Let's do static. I remember static. We'll do static variables, which I never use. I've intentionally not used them. What stack? Stack allocation. So usually when like for example here, like stack versus heap allocation. All right, so right here, this is a stack variable. It's just inline and it's just allocated inline, and it's not a very large data stack. Malik, you got it. Malik, you got it. Memory allocation, right? So malloc, sort of like, right, heap with malloc, right? There you go. Let's see, heap. There we go. All right, heap with malloc. What about file reader? Ooh, reading files. Right now you're getting into it, right? Reading files. What about reading standard IO? What it's stdio, right? I like that one. That's a good one. Direct from like a data pipe. Design a memory scheme such that you reduce reallocation and keep performance. Yeah, there you go. Now you're getting into it. What you want to do is grab as much memory as you think you're going to need for the entire application. Yep, you got it in std err. Yep, you got it. Reading and writing. Right, you could do those. I like that as well. There's so many things you can do. When we're doing bit shifts, probably logic operators, right? The logic operators, yep, you can do that. Yep, so you've got logic to do logic operators, bitwise logic operators, right? Bitwise versus bit shifting operators, right? You could do that. So there's different, so much fun stuff, isn't there? And this is just like one of the most simplest languages. It really is. It's just so simple. It's very lightweight. It's close to everything when it comes to the operating system and calling into, the supervisor, right? What music am I listening to in the background? Here, I'll show you. It's forever free licensed, unlicensed Creative Commons music on YouTube. That's how it is. How did you become a good at C? Hey, Black Scythe, good question. You just practice. And good news, there's only like 25 or so keywords in C. It's not a lot. It's one of the easier languages. Well, I mean, I really want to say it's one of the easier languages to learn. It is not necessarily the easiest, though at the same time, there's not a lot to learn. Probably Python will be a little more user-friendly if you're really getting into it. However, right now we're going to do some C. There's a lot on this list. We have so much, and we only have... Are we already low on time? How did time go by so fast? Are you kidding me? No way. All right, so I do have... We have about 30 minutes left, you guys. We've got 30 minutes. Let's see if we can go through some things. Let's go through... All right, so let's go through some stuff. All right, so this is still build and run. Yes, it does. It still builds and runs. I want to do that really quick and make sure... All right, excellent. Okay. So let's do a char string. Let's see if we can do that. And see if we can remember this. Char pointer. Here's a question. I want, it's a style pattern. It's a style guide. How do you define your pointer variables when you've got things like this? Char string, right? You can define a char string, and then you can say string equals malloc. I don't know. What happens if we do that? Can we do that? Is that going to work or is that going to crash? It doesn't like it. Oh, do we need standard lib? Okay. Let's see. stdlib. All right. So we need standard lib for malloc. Easy. Makes much meaning when we delve into assembly. Yeah, you're right. It does. C makes a lot more sense when you dive into assembly. You're absolutely right. How much back while making everything transparent? It is. C is just like this nice little thin layer on top of assembly. Great part is that it can target all the different architectures. So you can. The idea was it's portable. It's portable C. Whoever thought of that? It's portable C. It's not necessarily portable. Yeah, kind of portable. Where you've got this high level language that can then target a compilation for specific instruction sets on assembly. Yeah, that is pretty good. Passing address of variables to a function and modifying them instead of copying is good. Yeah, you're right. There you go. By reference. All right. By reference. Let's type that right. Reference var passing into functions instead of copy. Yep. See, that's a good pattern. So if you write a really powerful, fast and efficient application in C, it's going to allocate memory infrequently and have its own pool of memory that is managing over time. So if you have very few mallocs and frees, you're good to go. Because you don't have to... Calls to the operating system are expensive. So you want to minimize those. You want to minimize... Hey, $1.19, how's it going? Hello, I've come across your stream a few times. Lurk, but sometimes shout it out. And what you do on a regular is in line with what I'm learning. Hey, nice! $1.19. Sounds great. Right now you're doing some Python. Nice, Python. But you want to learn Rust or C next, not sure. Either is a good choice. Rust is going to be far more complicated. It's just more advanced. There's just more to it. C has fewer keywords, although there's a lot of strategies in C in order to get the most out of it. It teaches real base architecture when using it in RAM and IRQs. Oh, right. Interrupts. The interrupts. Or really a way in communicating back into the application user space from the kernel. The kernel, which also has access to the different hardware devices, and it gives you easy access to those programmatically. One of your goals is to contribute towards Linux. That's a good goal. That's a great goal. Make it happen. Exactly. Nice. So when will you deal for a stream on assembly? Oh, we can go back to it. So we've been doing some assembly. We did assembly. Actually, we've streamed maybe 2 weeks of assembly so far. So we can do more. We can do more assembly. We can do more. All right. So let's see here. Let's see. Will it build now? Will it build? Hey, there we go. We're remembering things. We are remembering things. I tell you what, things are happening. It just is. It just so is. And I do believe we can assign How do we put data into the string that we allocated it? That's the part I forgot about. And you said a bit expensive as it registers a context switch by the scheduler, or am I confusing things? Interrupt. Yes. So it's expensive to make a call to the kernel and ask for something. So like memory allocation, right? So like for this right here, memory allocation. Let's do free string. There you go. And then deallocation. So right there and right here at the same time. So these lines right here, these are the expensive lines, right? You want to minimize those calls because they slow things down. If you can just do all your work inside the CPU without having to make any calls out to the operating system, very fast, very efficient, super great application. It's great. I also have a good exercise for logic operators. At the same time, explain calloc. Oh, right. There's a different types of mallocs, right? I'll post it in Discord under free resources. Just look at once you're ready. Okay. Torva, thank you. Thank you, Torva. Right, malloc is triggering an IRQ on IR. Yep, here we go. Okay, so there we go. Okay, so let me see if that still builds and runs. All right, looks good. Now I want to put data. Let's see if we can put data into this. How do we do that? It's called like print. It's in order to like put data into the char array that we just defined. I forgot. There's like a special print for it. Put data into char. General chat. All right. Sounds good. No worries. General chat sounds good. Pull over there. We could also see, does that put, one moment. I'm just like, there's different approaches for putting, we could also, it looks like you can also do this, right? Something like that. You can put data straight in and then you don't need, I believe this does is this a stack allocation? Because it's right here, the data is predefined. So the compiler will have no problem putting this into a data segment. So this will put scanf. Is that it? Is that what I'm looking for? That might be what I'm looking for, right? Scanf. Let me double check this. Let's see. To put data into a char using scanf, you must first ensure pointer is blah 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 already allocated. Looks to go. Scanf. Name no %f. I'm looking up the scanf example here. Use the array name directly. Oh no, I still don't. Not let's see. Oh, scanf is gonna take data from IO. That's what that's gonna do. So right is that can take input from let's try this. Okay, let's try this. Let's try using the scanf function. I've not necessarily needed to use this before. All right, so one second. Let's actually comment these things out really quick. La 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 la. Looks good. Okay, this build and looks good. Okay, let's try scanf. So we'll do like this. Char string malloc. I think you can do like that, right? So try this. Check out the manual. Malloc doesn't trigger a system call unless it ran out of memory from the OS and you exceed what it's previously allocated. It depends, right? Depends on what kind of allocator you have. There's different allocators and different allocation strategies. You're absolutely right. The allocator can be optimized. And so what is there? There's different kinds of allocators. There's memalloc from Microsoft. There's jmalloc from Meta and Facebook, I think. And then there's varieties of other mallocs. You can use these, and what they do is they do make a call to OS to grab some data, reserve some memory. If over time, as you're calling them, they keep heuristics on what you're calling and using, and they start allocating larger or smaller amounts of data in memory. And then they will store data in addresses that are used in a shared pool. So you're right, Savan. There's varieties. Don't forget our loved ones. Recursion. Oh, yeah, recursion. Oh, let me add that in here. Right. Thank you, just a random. Recursion. There we go. Can't forget recursion. I didn't know that. That's amazing. Yeah. So we use varieties of different memory allocators at PubNub. We use different ones. We don't use the stock basic operating system one. The problem is, because over time, you can have problems, especially when you're dealing with the kind of data that we have, with fragmentation, which prevents memory being returned to the operating system if you don't need it as much anymore. Because we use terabytes of RAM. We use terabytes. Obviously, yep, memory fragmentation. You got it, memory fragmentation. So you want to use an allocator that is optimized to improve its memory usage and freeing back to the system when it possibly can. All right. Let's go over to the general channel really quick. Torva posted something over here. Let's see if we can read through this. All right. The library function calloc has the following declaration. Size and size. There's two different sizes. Okay. Wait, why? Oh, wait, no, still why. According to the library documentation, the calloc function allocates memory for an array of nmebs elements of the size of each byte. Okay, so you can have a size, or maybe like if it's like a certain data type, like a 64-bit integer, and then you can allocate the amount that you need. The memory is set to 0. Okay. Oh, it auto sets it to 0 for you, so you don't have to null it out. You don't have to clear it out. So is that what the C is for? Clear allocate? Is that what that's for? It clear allocates it. The memory is set to 0. If nmeb is set to, hey Gucci 300. Okay, if it's set to, where were we at? The memory set to 0. Blah blah blah. Allocate returns null. The calloc returns null if it's set to 0. Got it. Okay. Torva. Yep. Nice. Good to know. It's not about doubt. You can write any simple, then try to find out assembly instructions. Any function will be, and it'll work. All right. We might have to investigate that a little bit more. All right. Write an implementation of calloc that performs the allocation by call to malloc. And set the memory to 0, right? Via memset. Your code should not have any vulnerabilities due to arithmetic overflow, and it should work correctly regardless of the number of bits used. Represent of the, okay, so as a reference, function malloc and memset have the following declarations. This sounds like a fun task here. All right, Torva, let's see if we can do it. All right, let's see if we can do it. This might be a little bit beyond the basics of C, though it's not too far off. I mean, this does count. It does count. All right. So let's see here. Paste. Okay. Here we go. Okay. Delete. Okay. So we want to write our own calloc function. Happy Monday, Kyle. How's it going? Good to see you. We've got about 24 minutes left, then I got to jump out. I have a solution. I can send it at the end. Nice. Let's see if. All right. So we're changing things up. We're going to write our own calloc function, and a lot has been given to us. Avoid size malloc. Wait, void. Malloc is void. T size. Is it really void? 30 minutes and we have a deal? Oh, I gotta go. I've got meetings. I've got responsibilities. I've got things that I gotta take care of. And a lot of other work. It's the beginning of the year. It's busy. I want to spend time with you guys. I really do. I want to hang out. I want to write code. I want to play around. I want more AI algorithms. All right. So let's see if we can get this. Okay. Okay. It's gonna take some effort. Okay, so we need to write our own calloc. So, what was it? Void calloc. Okay. It returned nothing. Size T, N mebs. See, this is the part that I'm fair enough. Yeah. Yes, because the type is not determined yet. Oh, I forgot about. Shouldn't it be a pointer or something then? It returns no value, just assigns the var to memory using the reference out of memory. So do we return a pointer? I forgot. So calloc. I don't know if we're going to be able to. I don't know. We've only got a few minutes here. So let's see here. Void calloc. I can't remember. Me neither. Me neither. We'll see if we can do it. Torva said, "Hey, we should try this thing." It's like, "Okay, Torva. All right. Let's see if we can get it." All right, so we got this, and then we're going to call memset is easy, I think. Maybe. All right. Let's just define it here. From where to start using the allocated. Yeah, so we should do let's see, malloc, right? We should do a malloc here. We need size. Nmemb times size. Maybe. The only problem is I don't know how it's going to work from a data types perspective. Is this Rust? What are we doing? Oh, Kyle, this is C. We're just doing C basics. And just kidding, Torva was like, "Hey, let's do something a little bit more advanced." I'm like, I was thinking of just doing strings and printing data. Like, now we're going to write our own calloc. Well, I don't know if we... See, the thing is, I think this function might already be defined, although we're going to find out. Let's see, can we build it and run it? Is there going to be a problem? Previous declaration. See, that's what I thought. So we'll call this Steven underscore calloc. Let's see if that works. All right, better. Hello, you're back. Aiden, how's it going? Again, good to see you. You can then use a case to type if you wanted. Yeah, we need to do a type conversion, I think, at some point. At some point, we got to do a type conversion. Okay, so we need to void pointer data equals malloc. Let's just delete this. All right, so is that how we do that? And then we do memset data, and is that it? Actually, I don't know. Return data. Now, obviously, this is not safe. Oh, int star equals. Yeah, if we've got a specific data type, do we have to do that? I can't remember. Or some such. Yeah, malloc. All right, so there's just some random data of a certain size, right? Of a certain type, the number, and then the size. Is that going to build? Okay, memset function. Scroll up here. Call to undeclared library. Oh, we need to import this. Oh, include header string. Okay, so we need this guy. Okay, maybe. Okay, all right, there we go. Making some ways. Memset expected expression. Oh, so we need it wants. How do we use memset? I thought it was just. Oh, let's read through this more. Return data. Void function should not return value. Oh. Do we do that? Or do we do like the address of? Something like that. Do we have to do something like void pointer? We'll figure this out. Should not return a value. Yeah, but I mean we want to return a pointer? A void pointer? Okay, there we go. Making progress. I don't know if that counts. Are we cheating now? Because we changed some stuff. Voids int c size. Oh, okay. So we need some of this. Memset voids set, see, copilot disable. No. Okay. Okay, so there's more to memset. So this is the definition of allocate is easy. It's just one straight up. And then memset is going to say what the data is. So do I say data? It already is a data. Avoid. Built-in destination. Okay, destination, args, and then the size. So we need one more thing. Destination. Seems good to me. Int C. What is this? All right, so I don't know what this. I need to look this up. We need to look this up. What is memset? What is memset? Memset. We're gonna look this up really quick. All right, memset. All right. Okay, so we need a pointer to the starting of the address of the memory to block, which is this part right here. Right, so we got this part here, which is data. Easy. The second is the value to be set. Oh, 0. So do we just say 0? And then we say how much, the number of bytes to set. Okay, perfect. So memset, which essentially sets everything to 0, right? Is that what that does? I'm pretty sure. Okay. See if that is better now. Oh, hey, look at that. All right. Now we have to do a check, right? This could fail right here. This could fail, right? So if data, how do we check? How do we check if malloc fails? That's what I want to know. Check if malloc fails. All right, let's see. How do we do that? What comes back from malloc? Oh, it's just null. Then we can say goodbye. Return. Does that work? All right, let's find out. Oh wait, I'm in Python world. We have to syntax here. Okay. Hey, there we go. All right, Torva. I don't know if you got it right. So we got about 14 minutes left here, and we got to jump out. 2 to 3 years in what's Dagestan? And forgot. Oh, right. It's really easy, Anthony. It's really easy to forget, isn't it? It's really easy to forget. Will this cause the entire computer to crash, or is it perfectly fine? This part, I'm pretty confident this looks good. I'm pretty sure this looks good here. And then we just check to see, are you writing code? I am. 6PSY4CH2H09TWIT. Your name is kind of crazy there. We are definitely writing some code. Torva, who's in our Discord channel, was like, hey, Steven, you should do this. You should write your own calloc function. And I kind of did. So what we did right here is we wrote our own calloc function, called it Steven calloc. And that should do the trick as far as I can tell. It'll set everything to 0, every single byte. And it will do that. So I do believe now we can do our own calloc here. We can do Steven calloc like that. And that should work without probably issues. Oh, we need two. We need 2. Is it 1010? Oh, well. All right. Well, that works. It works fine. So yes, the logic itself is right. Only thing that breaks is the overflow. And when nim is 0. I forgot about user input. You bring up a really good bargain there. All right, so we got to validate user input. Okay. If nmem is less than equal to 0, then we also return none. I guess can we return null? Can we just do that? Does that work? It does. Hey, that's good. All right. Made it a little bit better. I know I'm just like making stuff up. Me over here returning a void pointer to nothing, to 0, just so the compiler can work. When you just return null. Forget about this. Yes, use the logic. You're right. Okay, so sir, with due respect, are you doing? This is C. You got it. We're doing C. I know C is an old language now. You don't necessarily want to use C directly anymore now that we have things like Rust and other higher level languages. We're doing this just to revamp on some things. Also, Torva in chat in our Discord channel said, hey, we should see if we can do this fun exercise, which goes beyond the basics. It's kind of the basics. It really is. I mean, I'd say it's like, it's not, it's just a step up above it. I was thinking like, super basics, like strings and pointers and for loops, simple stuff. All right, so validate user input looks good. And if they put a ginormous number in, then this will fail. So that's fine. So now we validated that. Also, we should probably also check this because we're doing a multiplication here. So we should check that either is not, right? Or size. Let's see. Size less than equals 0. There we go. Okay, so that, right? If either is 0, return null. So that's validate user input. Then we do allocate memory based on size. And then we do if allocation fails, otherwise set all memory. So this is a good way. So one of the things is with C, if you didn't know this, when you allocate memory, you're getting access to an address block of memory or a virtual table lookup of memory. However, the data that's already there that's been manipulated, it's still, I believe it's still filled with whatever it was, whatever the operating system left with it. They didn't change it. You have access to whatever it was before. So if you try to read or write to it, you're whatever. You're on your luck. You're on your own. So if you do a memset, it clears it all out, which is another write to memory when you don't necessarily need to do that. It's fine if you do it. It's just, I think you just need to be aware that in certain situations, you might want to zero it out just from a safety perspective. You don't have to, though in some cases you might want to. Your name is Psycho with 69 and 420 and Twitch all in one. Is it? I was not expecting. Okay, Torva pasted in the actual answer. I'm actually kind of curious to see it. I'm actually kind of curious to see what the actual answer is because we got 9 minutes left and we got to get going. Hey, you meant to ask, are you implementing any features or are you just coding for teaching sake? Right now, we're just resurfacing all the things that we used to know and actually came back really fast. It came back really, like within 10 minutes, we're like, oh, hey, I forgot about that. Because it's been a little while since, you write C and you've been writing Python and Rust and JavaScript and TypeScript over many years. And now it's like, hey, let's bring back some C. Oh, I forgot. It's actually pretty easy. Because you had seen you doing some docs the other day. Are you implementing this out of the doc or something? No, the docs was an expectation for software engineering in 2026, where we have code generation capabilities. It is a new set of expertise that professional software engineers need to know. So that is what we were working on previously. Now we're going to coding. I like to code from scratch by hand so we don't atrophy, because it's really easy to atrophy. Cora Bibor, thank you for subscribing. Welcome on in. This channel is about software engineering. We focus on technology and other things. So I'm Stephen Blum, CTO at PubNub. We have over 1 billion devices connected to my network and 68 patent claims that have already been granted. I've been in tech for 25 years, professional tech, right? So actually making money for 25 years. I've been doing for fun, like as you know, in the early years, practicing coding and learning coding in the early years, and then 25 years professionally. So yeah, thank you. Then on this channel, we focus on artificial intelligence, coding from scratch, Python, JavaScript, Rust, mostly focusing on AI. Today we're doing C with basics. We have about 7 minutes left, so just a few minutes, and we're going to go over Torva's answer here. You look 25. I know, it's like we're pretty old already. We're pretty old. We're over 40. All right, we're over 40 years old. Have you heard of the Primogen? Older than the Primogen. Bro, what you're doing every few days, you switch languages like it's something new. I know, right? We're all doing something new. We're making things happen. It's like some new dish. Yeah. So we're going based on your requests. So we're here for you. That's why I'm here. I'm here because of you guys. If you weren't here, yeah, bro, you look 25, dude. I know. It's like, I stay inside and I look at the computer all day. So I shall subscribe. I'm admiring your work on profile. Thank you. Thank you for your subscription. Good to have you here. And yeah, so we focus on my code editor is Vim. I use Tmux as my window management inside of the terminal emulator. And I use Ghosty because it's hardware accelerated, it's fast, and it's modern, and it supports full colors. It's really neat. And I use the Groovebox color scheme. It's fantastic. And so let's go, since we only have about 5 minutes left here, and I kind of got it working. It compiles, and it works, and it didn't crash. So I will be sending connection request in LinkedIn. Please accept. All right. Short Mania. Sounds good. What Linux distro to use? Uname. Here you go. All right. Uname. Uname with actually out the quote symbol. Let's do this. Where Uname. I know how to type on the computer. There you go. Darwin. There you go. Darwin right there. I'm 32 and my birthday is this month. Nice. I love how learning about coding anything really. That's what we're doing. Coding about anything. Thank you for all you're doing, Stephen. Hey, don't die 88. Thank you. Oh, thank you for being here. It's great that you guys are here. I will work on Spring Boot Java database and AWS, Amazon Web Services, and some Angular on JavaScript and TypeScript probably. Sounds good to me. Name of the profile, Short Mania. Just do Stephen Blum. You should be able to see me. You should be able to find me. Darwin. I know, Darwin. Have a good day. You too. You too. We got about 5 minutes left. Let's go over Torva's example here on Discord. Let's go over Torva's example. All right. Here we go. Here's the actual answer. We'll copy and paste this. All right. We weren't too far off. Hey, look at that. Oh, total. That's a good idea to make a total. I like that. All right. So let's see what AngularJS is an awesome framework. Yeah, it is. They did a good job. Set paste. Okay. I would love to stay with you guys longer. I do have a meeting that I get to get to. So here is the Torva version, the calloc. Torva calloc. Okay. So, hey, if it's 0, I just said less than or equal to 0. Obviously, what if the user puts in a negative number? Torva. Come on, Torva. What if the user puts in a negative number? Right? Mine's covering a case of negative numbers. You sent the request? Nice. All right. Let us go to this here. All right, we'll pull it up. And we'll scroll over to it. Where is it at? Right here. Satya? Is this you, Satya? How can a beginner start from? Do you have advice on it? Yeah. So David, good news. We were basically starting. So we'll do more of this tomorrow. Or maybe a little bit more today. I'll find out. I might go later today though if we jump back on. What are we building today, Short Mania? We are just we're doing a calc. Torva gave us this strategy. Said, hey, check this out. Maybe it would be fun if we wrote our own calloc function, and we did. And so we did pretty good. Oh, there's also a size max. We could do that too. I was just relying on malloc for that. Relying on malloc. You also did a size. This is interesting. I'm not sure about this syntax. Can this work? Is it supposed to be this? Is it missing something, Torva? So we got 2 minutes left. So Torva, if you're still here, was that wrong? Is that a typo? Will that work? I don't even know if that works in C. Let's see if that works. Let's try to build it. It builds. I don't know how. I don't know why. Torva, you can really do that? Oh, it's you, Satya? Okay. Accept. There we go. All right, 1 second. And then it'll pull us back over here. And then I'll send you a message. I will send you a message. Let's zoom out here for a smidge. Okay. Hello. There you go. Sent you a message. Sent you a message. Now we are connected. We are now connected. All right. SAQ 3000, how's it going? You're late to the stream? Yeah, because we're about to leave. We've got 1 minute left and we got to get it going. It's good to see you. Thank you guys for hanging out with me today. I might be back on a little bit later or tomorrow. Depends. We'll continue doing some C programming. Just getting wrapped back up. Obviously, we've been doing a lot of, with generative coding with Claude Code. And it kind of makes it to the point where you forget about a few things. It comes back pretty quick. Thanks, man. I'll follow yours. Thank you. Sounds good. Say my name. Shri Xiao. I'm trying to say your name. Good night, dude. Thank you guys for hanging out. Shri Xiao. Shri Xiao? It's been a pleasure. Torva, thank you. Yes, Torva, thank you for the thing. Looks like we got pretty close. We did pretty good. The only thing I didn't do was this, and I just kind of relied on that. I didn't know you could do this. It's pretty neat. When you're streaming tomorrow, about the same time, around the same time. All right, everyone. Thank you for hanging out with me. We'll be back tomorrow. We'll be doing more C coding, some more C basics. Steven, you get in stream. I want to show you one Mandela effect. We've got 10 seconds. Hey, you're out of time. You're out of time. It was great. It was great having you all here today. We will be back tomorrow. It was a lot of fun hanging out with you guys. We'll see you guys tomorrow. Enjoy. SAQ 3000. I might be back on later today, or send them out Mandela effect thing a little bit later when we go live. Do you compile? Yes. Here you go. Compile and run. There you go. It's right there, David. See, we compiled and run right here on the screen. Shri Xiao. All right. Thank you guys. I got to get going. Good to see you. We'll be back. We'll be back a little bit later. Bye, guys.